All right, 17, our first Taylor polynomial multiple choice question. They start off with a function f of x equals 3 log of 3 minus x. And we need to find the third degree Taylor polynomial. So that's going to require us to do 3 derivatives of this function. I've got 1 over 3 minus x times negative 1, and I'm going to write that as negative 3 minus x to the negative first, just to help us out with the derivatives. Second derivative is going to be positive 3 minus x to the negative second, but also times negative 1 again. And so that's going to give me negative 1 times 3 minus x to the negative 2. Third derivative is going to be a positive 2, 3 minus x to the negative third times negative 1, and that's going to be negative 2 times 3 minus x to the negative third. When I evaluate 2 into each of these, I'm going to get log of 1, which is 0. 2 in this one is going to give me negative 1 to the negative first. So that's just negative 1. That's f prime. F double prime of 2 is going to be negative 1 times 1 to the negative 2. So that's also negative 1. And the third derivative is negative 2 times 1 to the negative third, which is negative 2. Remembering my Taylor polynomial formula for the third degree Taylor polynomial, I want the value of the function at 2 plus the value of the derivative at 2 over 1 factorial times x minus 2 plus the second derivative at 2 over 2 factorial times x minus 2 to the third, plus the third derivative of at 2 over 3 factorial times x minus 2 to the, this one should be the second, this one should be the third. All right, and so I just have to go through and plug in what my derivatives are for each one of those. So my first term is 0. My second term, the first derivative at 2 is negative 1. 1 factorial is just 1, so this is negative x minus 2. This next one is also negative 1, so it's negative 1 over 2, which is 1/2, x minus 2 squared. This next one is going to be negative 2, right, over 3 factorial, and that simplifies to just 1/3, x minus 2 to the third. So looking for that pattern, every term is negative. I have powers that increase by 1, and I have, this one should be minus. Sorry about that, minus 2. And I have coefficients that are negative 1, negative half, negative 1/3. So it looks like B is our best answer for 17. 19. This problem's about interpreting integrals as areas. It tells us that A is representative of that integral, and then a sub 1, a sub 2 is the positive area of this, right? Positive area of this. So when I look at the integral from negative 4 of f of x dx, that's the integral of the entire region. If these are positive areas, what it's going to end up being is the area of A1 minus the area of A2. And the integral from negative 1 to 4, if A2 is that area, is going to be the opposite of A2. And so the expression I have right here is A1 minus A2 minus 2 times negative A2. And that ends up being A1 minus A2 plus 2A2. And that gives me A1 plus A2. Our answer there looks like D.